Okay, part 2 again, as I said last video, 3 parts. So the first part of part D is to have a case where k equals 2, and that's what we've got there, and it asks us to find the equation of the tangent. So that's obviously the equation of the line or the curve that comes off a given function at a given point. So find the equation of the tangent at the curve at the point. And again, that's using info from the last video, which had part C in it. So I just abbreviated that question, and the first part of this says, and this is for 2 marks, P is 2, 4, and it wants us to find the equation of the tangent to that. So in the last video, for 3 marks, we worked out, or we showed that the dy over dx is equal to, of course, y take 2x over 2y take x. So now what we do is we simply find the corresponding slope to that. This gives us a slope at a given point because it's a derivative. It's a function that represents a slope. So we have an x value of 2 here and a y value of 4. So we simply substitute that in to get the slope. So dy over dx. In fact, I'll actually use some alternate notation here. We have the f prime of 2 when y equals 4. And we have 4, which is our y value. Take 2 lots of x, which is 2 lots of 2, which is going to make over 2y, and y is 4. Take x, which is take 2, which is going to simplify down to, and hopefully I have enough board space. No, obviously not. Slanting again, sorry, but that's going to give us a slope of 0 over, because 4 take 4 is 0, and then 2 times 4 is 8, take 2 is 6. So it's going to be 0 over 6, which is going to equal 0. It's not going to be undefined because 0 is in the numerator. So therefore, if we look at the equation of our tangent, we have y subtract the y coordinate, and the y coordinate is 4, over x subtract the x coordinate, and x coordinate is 2, and that equals 0. Now we want to get this into y equals mx plus c form, where y is obviously our input, m is the slope, x is our input value, and c is our y-intercept. So we're going to be able to get a function from that. So y take 4 is equal to 0 lots of x take 2. I just moved this from the denominator on the LHS to the numerator on the RHS, and then from that we expand that and we see that we get 0 times x, 0x, and 0 times negative 2, which is going to make us pretty much have 0 there. So y take 4 equals 0, and then because this is actually a negative here, we can take it to the other side and it's going to be positive, so therefore y equals 4 is that equation. And if we had a look at that on our original graph, it would just be a line like that. So we've got y equals 4 as being the equation of the tangent at P. So based on this coordinate point, if this coordinate was on the function where our k equals x, then on the actual function that we have there, we would see that the slope of the tangent would be equal to 0, and therefore we would just have a flat line. Okay. So that was the 2 marks. Now we just repeat the process, and we slightly change it because we're given the other point, which of course is going to be Q. So instead of P we have Q, but it's probably important to note P up here because it will come in handy for the later question. So we have P, in fact the tangent to the point P, I should say. So in fact I'll just write it as y equals 4. It's probably easiest. But for this one, we have Q, and we have 2 as our x-coordinate, because of course it's on that x equals k, where that's on the x equals 2 line, but in this particular scenario it's 2, negative 2. So the x-coordinate is 2 and the y-coordinate is negative 2. Okay, and therefore from this, what we do is we repeat the same process, but y is equal to negative 2 now. So we have, just substitute it to find our slope of the tangent, and we get y is negative 2, so it's negative 2 take 2 lots of x, and x is still equal to 2, over 2 lots of y, and y is equal to negative 2, take x, and x, of course, is equal to 2. So therefore what we get is we get negative 2 take 4, so we're going to get negative 6, and that's negative 6 over, and it's 2 times negative 2, which is going to make negative 4, and then negative 4 take 2 makes negative 6. So we get negative 6 over negative 6, which is also equal to 1, because a negative divided by a negative makes a positive. Okay. And from that, we have y take the y-coordinate, so it's actually going to be y plus 2, and then it's over x take the x-coordinate. And the x-coordinate here is just normally 2, so it's take the x-coordinate, so it's x take 2. Excellent. And now what we do is we set that equal to our slope of the tangent, and therefore y plus 2 equals, and that's just 1 there, so we're bringing this up from the actual denominator of the LHS to the numerator on the RHS, and as a result we get x take 2, because the 1 does not affect it. It's just one lot of itself. And then what we do is we have y plus 2 equals x take 2, so we bring this positive 2 and we move it to be negative 2 on the other side, so that simplifies down to x take 4 as being the second equation, y equals x take 4. And that was another 2-mark question, so we solved 4 marks in the beginning of this video, and I'll just make sure you can see the negative 4 down there. Yep, and I really need to learn how to not write so slanty, but that's okay. So now what we do is we go on and say, well, the tangents in the first 2 parts of this question, we had I and then we just had I there. The tangents that we got, the equations, they intersect at a point which is represented by T, and we need to show that the triangle formed from P to T to Q is an isosceles triangle. And this is worth 2 marks. Okay, so we've got our equation still up there, and we need to solve that this is an isosceles triangle. So what's the best thing to do? Probably plot it, I would say. So we plot these functions roughly where they'd be on the Cartesian plane. So we have P, and P, of course, was 2, 4. And then we have Q, which was 2, negative 2. Okay, so we had P, which was 2, 4. So if we had a Cartesian plane, so that's 2, and say that's about 4. So we had P here. And then we had Q, probably down here. Okay, so we've got P and Q, and then we can draw in their tangents. Y equals 4. I'll just do it as a dotted line. And then we had y equals x take 4, which I probably won't draw in as a dotted line just yet, because it probably isn't really needed at the moment. Okay, so we have our 2 functions, y equals 4, and y equals x take 4. And we know from linear algebra that if we set them equal to each other and find a common x-coordinate, that would be the point of intersection. So therefore, 4 equals x take 4. I've set the 2 functions equal to each other, and I'm going to find a common x-coordinate. So therefore, x equals, and what we do is we actually have 4 and take 4, so we bring this 4 to the other side. So because it's negative 4 and it's going to be positive 4 on this side, it's going to be equal to 8. X equals 8 because it's negative 4, so it's going to be positive 4, and then positive 4 plus 4 is going to be equal to 8. And that gives us our common x-coordinate. And that's going to be T, the point where the 2 lines intersect. Okay, and now what we need to do is find the y-coordinate from that. So that's easy, because what we need to do is we just need to simply substitute x into our equation, and because we know that y is equal to 4 and it's that dashed horizontal line, we know that, of course, the point of intersection must have a y-coordinate of 4. So if we were to plot this on the graph, we'd have 8 somewhere out here, and it would be 4, so it would be there. Okay, and now we need to prove that this is an isosceles triangle. So I need to prove that PTQ is an isosceles triangle. And in order to do this, we just survey the distance between P and Q, and of course, that should be T, sorry. P and T and P and Q. Okay, so this is at y equals 4, and that's at y equals -2. So we have 4 vertical, and then another 2 beyond the axis. So that has a length of 6 there. And then P to T, this is at 2, that's at 8. So we move 1, we get to 3, we move 2, we get to 4, and we keep moving across. And of course, if we move from 2 to 8, that's a movement of 6. And then Q to T is, of course, using Pythagoras theorem, easily solved. So we have c squared equals a squared plus b squared as being the general form for Pythagoras theorem. Therefore, c squared equals 6 squared plus 6 squared, because p, t, and pq are both 6. And therefore, c equals, and 6 squared plus 6 squared, that's obviously going to make 72. So it's going to be the square root of 72 units. And an isosceles triangle just means that two sides are the same. So we can prove that it's an isosceles triangle because the length PQ is equal to the length PT, which is equal to 6 units. And the good thing is, didn't quite manage to make it actually fit in there. But PQ is equal to PT, and therefore it's equal to 6 units, and hence the triangle is isosceles because these two sides are the same. Okay, and that is worth 2 marks there. So all up, this question was worth, let's see, we have 3 marks for A and B, then we have another 3 marks for C, so that's 6, and then plus another 6, so it was worth 12 marks all up, that question. So yeah, it's just an example of what could possibly be in the exam, and it's quite an interesting thing. We looked at implicit differentiation here, we looked at finding equations of the tangent, we looked a little bit at proving some distances, and we also looked at actually finding coordinates for P and Q, and drawing on graphs as well. So hopefully you felt okay with that. If there's any questions, please leave them in the comments section below. Thank you very much for watching. Goodbye.